Good morning. This is the second video for Calculus section 3.3, where we are using what's called the first derivative test for finding extreme values. So we're finding maxes and mins of a function. And what you'll notice here is that the process we did yesterday, which was finding increasing and decreasing intervals, really that's most of the process to do this. There's just one conclusion we have to make after we're done making that table sign chart thing from yesterday. So really this is kind of a continuation of that conversation. All right, so here is the actual first derivative test. And it's a little wordier than it actually, it's simpler than this. So the first derivative test says this. The first sentence says this, and the second one is just kind of the opposite. It says, I'm reading this sentence right here. It says, if the derivative changes from negative to positive at some value c, then there's a minimum value at the point c, f of c. Let me remind you what I need you to know that means. It says if the derivative changes from negative to positive, it has to become clear that if the derivative is negative, that means the function is decreasing. And if the derivative is positive, that means the function is increasing. Which means that this first sentence, which says if f prime of x changes from negative to positive, that's the same thing as saying if the function changes from decreasing to increasing. And if the function changes from decreasing to increasing at a point, then there's going to be a min at that point. Second sentence here just says the opposite. If the derivative changes from positive to negative, which is the same as saying if the function changes from increasing to decreasing, then there's a maximum. Third sentence says, be aware it might not change at all. Oops, sorry, my picture's gone, not sure where it went. Sorry, let me see if I can find it here. There it is. I can't find it. I'm going to pause. Can I get my picture back? All right, oh well. So the third one says if f prime of x is positive on both sides or negative on both sides. So if the derivative is positive before the value and then positive again, that means the function is increasing up until c, and then increasing actually there would not be a positive, a max, or a min. And then the last sentence here says it's got to be continuous for that to happen. Remember, if the function or the derivative is not defined, that could still be a critical number. That could still change where it's increasing or decreasing. But like if there's a vertical asymptote in a function, then just because it's changing, that would not be a maximum. So having said all of that, what I want to do here is 1, 2, 3, just 4 examples of kind of the same thing. So it's going to be a lot of the same processes yesterday, which is taking the derivative, setting it equal to 0, solving for x, creating that table, and finding increasing and decreasing intervals, and then from there, determining where there might be a max or a min. Okay. So I'm still trying to get my picture back on the screen here, but I don't know how to do it. Let's go here. Nope, not there. Appreciate you bearing with me here. Can I double click this? Nope. All right. I go like that and like that. It's not there either. All right. So heck with it. All right. Let me go back here then. Sorry for that confusion. All right. So here we go. First one is just a parabola. So we can do this one fairly quickly, I think. So clearly the derivative of this is what? 2x plus 6. And that's never undefined, but if I set equal to 0, I get 2x equals negative 6 and x equals negative 3. There's my critical number. Now, it is true, we know this is a parabola opening up, so it's going to be a min at x equals negative 3, but we want to use this process to show that. So if the critical number is negative 3, I'm going to make this table. My first interval goes from negative infinity to negative 3, and my second interval goes from negative 3 to infinity. And remember, I'm going to pick a test value in each interval. I'll pick negative 4 on that one. I'll pick 0 on that one. And now I am finding the sign of f prime. I am putting the test value into the derivative. My derivative was here. And I just want to know whether it's negative or positive. And if I plug negative 4 into that derivative, I get a negative number. And if I plug 0, I get a positive number. So that means that's negative and that's positive. So what we did yesterday, the conclusion we came to yesterday, some more space here, is this function is increasing on the interval from -3 to infinity, and it's decreasing, and it's increasing because the derivative was positive, and it's decreasing from -infinity to -3 because the derivative was negative, and by the first derivative test at -3, since the function changed from decreasing to increasing, I will say there is a max, no, that's a lie, a min at x equals -3. And if this is important on the AP test, if you have to justify that, while this sign chart is kind of all the work, you have to explain why you concluded that. So I'm going to say since f prime of x changed from negative to positive at x equals -3. Understand, I also could have said since the function changes from decreasing to increasing. And notice, if the question is what is the minimum value, we haven't answered that question. We would have to, like, how low does that function get? We would have to plug -3 back into the original function, and we could do that, but this just wants to know at what x values there would be a min or a max. So that was a pretty simple one with a parabola. Next one is a cubic. So let's see what happens here. So again, we will take the derivative. F prime of x is 3 times x minus 3 squared times the derivative of the inside, which is just 1. So again, I need to figure out where this equals 0 because it's never undefined. I can divide both sides by 3. My light's just turned off, but you maybe can't tell that. I'm going to turn it back on anyway. I divide both sides by 3. I get x minus 3 squared equals 0. That's an equal sign, sorry. Oop, there we go. I square root both sides. I get x minus 3 equals 0 and x equals 3. There's my critical number. 3. Only appears to be one critical number. So again, I think I can fit this here. My interval, the first one goes from -infinity to 3. Second one goes from 3 to infinity. I need a test value. I'll pick 0 there and 4 there. Again, I'm finding the sine of f prime. Well, my derivative is, where's my derivative? My derivative is this. And I'm plugging in 0 first to see whether it's positive or negative. And if I plug in 0, I get -3 squared, which is positive, times a positive. That turned out to be positive. If I plug in 4, I still get a positive squared times the positive. So now we got to be careful here as we answer this question. The question says find increasing and decreasing intervals. At 3, the derivative is 0. There's a horizontal tangent at 3. So this thing is increasing. You cannot just say from -infinity to infinity. You have to break it from -infinity to 3 and also from 3 to infinity. That's the increasing intervals. There are no decreasing intervals. And since the derivative never changes from positive to negative or negative to positive, there is no max or min. And it's worth knowing what this function looks like. This function looks like this. 1, 2, 3. It's a cubic. At 0, officially it levels out. I didn't draw very well, but it would officially levels out where there's a horizontal tangent right there. But clearly it's increasing until 3 and increasing again after 3. So there's an example where every critical number doesn't have to be a max or a min. Again, we would need the function to change from increasing to decreasing or vice versa, which would mean the derivative changing from positive to negative or vice versa. So that one didn't have any. All right. I think I've got 2 left. I think I've got 2 left. All right, here we go. Now, a little trickier derivative. I don't know what this function looks like, certainly. Let me go to the picture of the book here so I can make sure it looks like it should look. All right, so let's find the derivative. I guess I need to quotient rule this. F prime of x is the bottom times the derivative of the top minus the top plus 1 times the derivative of the bottom, all over the bottom squared. Clearly, I want to set that equal to 0. It's going to be easier to do that if I can make that simpler. So let's, in fact, do some algebra here. I'm now simplifying the derivative. This is 4x to the 5th, and I'll distribute that minus 2x, so minus 2x to the 5th minus 2x over, what's that, x to the 4th. I'll keep simplifying. This is 2x to the 5th minus 2x all over x to the 4th. I think I can take an x out of the top. Heck, I can take a 2x out of the top, leaving me with x to the 4th minus 1 over x to the 4th. I can cancel, well, that's a 4. I can cancel one of the x's. I end up with 2 times x to the 4th minus 1 over x cubed. There's my derivative. Okay, I need to know either where that derivative, this is f prime of x. I need to know either where that derivative equals 0 or where that derivative is undefined. And remember, where it's undefined is where the bottom would equal 0, and that bottom would equal 0 at x equals 0. And the top, or where the derivative equals 0, is where the top would equal 0. And the top I could factor into 2 times x squared minus 1 times x squared plus 1. And then that first parentheses factors even further into this. That last one doesn't factor. So I've got 4 factors. And I would argue that 2 never equals 0 and x, there's my parentheses here, and x squared plus 1 never equals 0. But these 2 factors lead to x equals negative 1 and x equals 1. So I've got 3 critical numbers. One where the derivative is 0, that's x equals 0. And then 2 where the derivative, I'm sorry, the x equals 0 is where the derivative is undefined. And then these 2 are where the derivative equals 0. Now, let me go back to my original function. I would argue that original function has an asymptote at x equals 0 because it makes the bottom 0, not top. So there's a vertical asymptote at 0. Let's keep that in mind as we make our table and then determine maxes or mins. So my critical numbers were negative 1, 1, and 0. So my table, my first interval is from negative infinity to negative 1. My second interval is from negative 1 to 0. My third one is from 0 to 1. And my fourth one is from 1 to infinity. I need a test value. I'll pick negative 2. I guess I have to go with negative a half there and 1/2 there and 2 there. Now, I need to take those 4 test values and figure out the sign of the derivative. So let me go back and find, again, I said this yesterday, the derivative is, well, the derivative is this, but it's also, it might be easier. Let's see. I think that maybe the factored 4 be easier. I might leave it at that 2 times x to the 4th minus 1 over x cubed. And we'll go back and forth here. We're taking these test values and we're plugging it into the derivative to figure out whether it's positive or negative. So first, let's look at the first, which is negative 2. If I plug negative 2 in there, right now, again, I'm trying to find f prime of negative, that's a prime of negative 2. Well, that's 2 times negative 2 to the 4th is 2, 4, 8, 16 minus 1. That's all a positive. X cubed is going to be negative 8. So it's a positive over a negative, which is a negative. Next is negative a half. Now, let's think about that. I'm plugging negative, again, I'm not sure how much you need to write down versus think your way through. If I plug negative a half into the bottom, I get negative a half cubed is clearly negative. On the top, it says x to the 4th. Negative a half to the 4th is negative a half times negative a half times negative a half times negative a half. It is positive like 1/16, which minus 1 would be negative. So it turns out I have a negative over a negative, which turned out to be positive. All right, let's keep going. Plugging in 1/2. Very similar. The bottom is 1/2 cubed, which is positive. The top, I have 1/16 minus 1, which is negative. So I have a negative over a positive, which is negative. And then when I plug in 2, I think I get I have a positive on top and a positive on the bottom. Turned out to be a positive. So let's be real careful what conclusions we're able to make here based on this. First, the first part of the question said identify intervals where it's increasing or decreasing. Well, clearly I can do that. This thing is increasing from -1 to 0 and also from 1 to infinity. And this thing is decreasing from -infinity to -1 and also from 0 to 1. That's like so far all I've done is the same thing that yesterday asked. Okay, but now I need to know maxes or mins. It looks like at -1, the derivative changes from negative to positive. That means the function is changing from decreasing to increasing, which would mean a min. At 0, the derivative changes from positive to negative, which means the function changes from increasing to decreasing, which would mean a max, but I'll remind you that the original function had an asymptote at 0. So that is not a max because the function is not even continuous there. And then at 1, the derivative changes from negative to positive, which means the function changes from decrease to increasing, so that would be a min. So there is a min at x equal -1, and there's a min at x equals 1, and that's it. And if I were to sketch that function, it happens to look like this. I've got the asymptote at 0 as promised, and it looks like all about like this and like this, where that min and that min are at -1 and 1. That's what that function looks like. All right, last example. I figured we can't do a bunch of examples without doing a trig example. So same process. Let's find the critical numbers. Notice for the trig ones, I have to be given some sort of interval because it's going to oscillate forever. So I'm just, instead of starting at -infinity and ending at infinity, my intervals will just go from 0 to 2 pi. All right. So let's see. I need the derivative. So my f prime of x is just 1/2. And then the derivative of minus sine would be minus the cosine of x. All right. I need to set that equal to 0. So that would be 1/2 equals the cosine of x. So where does the cosine of x equal 1/2? Again, I'm always visualizing my unit circle. Cosine is the x value, which is, so it'd be like, right, it's this 30, 60, 90 triangle right there, where that's a half, or down that way, so it'd be there, or there. So you've got to know that that's pi over 3 up there, and that's 5 pi over 3. There are my critical numbers. So my intervals, first one goes from 0 to pi over 3. Next one goes from pi over 3 to 5 pi over 3. That's a 3. And my last one goes from 5 pi over 3 to 2 pi. All right, I need a test value in each interval. I might pick pi over 6 for that one. I might pick pi for that one. And I guess I have to pick 11 pi over 6 for that one. Now, what's my goal with these test values? I am finding the sign, that's SIGN, sorry for the trig confusion, of the derivative. Well, let's see, where's my derivative? My derivative is, there's my derivative, 1/2 minus cosine x. So, pi over 6. Well, I have my unit circle, I'm going to use it. Pi over 6 is over here. The sign of that would be the y value, that's 1/2. Oh no, I want the cosine, 1/2 minus cosine. So the cosine of that would be √3/2. So it'd be 1/2 minus √3/2, which is negative, because √3/2 is bigger than a half. If I plug in pi is over there. The cosine of pi is the x value, that's -1. So it's 1/2 minus -1, which is 1/2 plus 1, which is positive. And then 11 pi over 6 is over here. And again, the cosine is still that positive √3/2. So that'd be 1/2 minus √3/2, which is negative. So this one, again, where is it increasing? On the interval from pi over 3 to 5 pi over 3. Where is it decreasing? From 0 to pi over 3, and also from 5 pi over 3 to 2 pi. And now what was new is just where the maxes and mins. So let's talk about right here. At pi over 3, the derivative appears to be changing from negative to positive. That means the function's changing from decreasing to increasing, which means there's a min at x equal pi over 3. And then here in green, At 5 pi over 3, the derivative changes from positive to negative, which means the function changes from increasing to decreasing. And the first derivative test tells you there's a max at x equals 5 pi over 3. And again, what does this function look like if I were to sketch it from 0 to 2 pi? It actually looks like this and this and this. So there, right there, is the pi over 3, which is where there was a min. And right there is 5 pi over 3, where there was a max. Okay, so 4 fairly quick examples. And your assignment has several more of the same. And I will tell you that there's the assignment. And I will tell you that during the live lesson tomorrow, you're actually going to be in small breakout rooms doing a couple of these together. And I'm going to kind of bounce back and forth and help along the way. So I need you to work through these today so that you're ready to just try. I think I'm going to just do 2 tomorrow. Have one of them much simpler and one of them a little strict, whether it's a trig one or an asymptote one or just so one easy, one a little more difficult. So that's the plan for the live lesson. So make sure you're there tomorrow during first bill. All right, that is all I've got for this. So let me see if I can figure out how to turn this thing off. So again, sorry for the camera confusion and have a great whatever day today is, Tuesday.